always do a visual inspection. You want to complete a visual inspection and you want to look for a lack of, an absence of smashed cable, crimped cable. Don't want to see any of that. Don't want to see any visual broken strands of your cable, or blackened cable, or patinaed cable. You don't want to see any of that, or bubbled jacket. All right? You don't want to see any obvious cracks in your clamps or loose components, and you don't want to see any oxidization on your components, especially the contact points. Then that's the visual. Okay, so if your TPGs look good and they're lacking all those things, typically they're going to be great for you in the field. If they look good, they're going to do great. So that's what you're going to look for. Mechanical inspection. We want to go ahead and grab a hold of that clamp, make sure that clamp does not twist off the ferrule, spin off, make sure that the cable is nice and tight in the crimps of the ferrule. Make sure that cable is nice and tight. So we're going to simply do an electrical test. I'm going to run this in parallel to mimic being used out in the field. You're going to, when you use these, you're going to go from point A to point B. You'll have some, typically a little droopage, because maybe they're just a little too long. That's fine. So we're going to mimic a parallel configuration, and this mitigates your magnetic field right here. This mitigates. So this is going to be in line and true to how you're using it out in the field. And so we're going to go to our tool, turn it on, and it requires a number 2 cable, which is this is a number 2, which is, to me, is way too small. You want to use a 1/0 or a 2/0 at least, because they're not as flimsy. Okay, and what we're going to do is we're going to put 165 amps. There's an amp meter down here. Can you get this, David? You got that? Okay, amp meter right there, and we're going to go to 165. And I can feel that current in my hand. And it feels kind of cool. Okay, we'll go about there. Okay, so we got about 100, little over 165, and we got a 0.228, so let's call it a 0.23 voltage drop. You go to the chart, it requires a 0.24 or less, so this passes. All right, and you can feel that continuous current. Like I said, it feels kind of cool. But anyways, the tool is very safe. You have very little voltage, so there's no shock potential, so I can touch it. Okay, so it's a very safe tool, and the safety that's in this tool, you'll see as we go further on that we put safety in all these tools similarly. When you coil it up, that's like transformer, right? When you coil it up, that's where you're going to produce and create a magnetic field. So we're going to crank this up to 300 amps. You see that? And that current's feeling kind of robust right now. I like it. All right, here we got a bottle. It's got a magnet in it. All right, so check out what happens. Here we go. Okay, you guys see that? A lot of activity. That's a magnetic field. That's not theory, that's reality. Huh? We're going to prove a lot of reality here today. You guys don't work with electrical theory. You work with electrical reality. All right, so that's what we're going to talk about. So if I go parallel, keep those amps exactly the way they are, and I go parallel, okay, same scenario, magnet in a bottle, watch what happens. Just a little hum, smoother, because we mitigated that magnetic field. So in other words, if you've got grounds, you don't want to leave them on the ground, coil them up so it looks all pretty. You don't want to do that. You want to string them out and run them out of your truck reel, your ground reel. You want to string them out and run them side by side to each other, or in just a long fashion. That's how you want to use your grounds. Does that make sense?